All right, so 8.5 is our last new lesson of the unit, and it's about rational and irrational numbers and what the difference between the two is. So we have all different kinds of numbers. Right now we've been working, in your whole lives you've been working in the real numbers, meaning numbers that you can plot on a number line. Within the real numbers, so we have real numbers, which is this really large group. There's a type that we call rational, and the other type called irrational. But they're all real numbers. So today we're going to look specifically at the difference between rational and irrational numbers. The easiest way I can think of to explain rational is that they are numbers that can be written. Oops, I'm going to run out of room. As fractions. So for example, the number 2, that's rational because we can write it as 2 over 1. 1/2, we can write that as a fraction, 1 over 2. 0.75, that can be rewritten as a fraction, 3/4. 0.333 repeating, that's 1/3. Okay, all of these that can be written as fractions are considered rational. Irrational are numbers that cannot be written as fractions. Cannot be written as a fraction. So what kind of numbers cannot be written as fractions? Well, a number like pi, because that's approximately 3.14, but in reality it keeps going forever and ever and ever. And because we don't have an end point, we can't write it as a fraction. Something like the square root of 2. Again, we can do the square root of 2 in a calculator, and we get 1.414 and a bunch of other numbers, but it never repeats. So because it never repeats and it never ends, it can't be rational. We can't write it as a fraction. So the types of numbers that are irrational are going to be the never-ending decimals, never-ending, and never repeating. Decimals. And so usually a radical like root 2 or even the square root of 3, any radical that when you simplify it leaves you with a radical, still that's going to be irrational. So root 3, root 5, root 7, all of those are irrational. Now if I said square root 4, well, what's the square root of 4? Square root of 4 is 2, and 2 can be written as a fraction. So if you can reduce it and get just a number, it's going to be rational. If you have a radical that doesn't reduce, it's going to be irrational. So what we're going to look at today are 6 examples where we're just going to simplify each expression. If we don't have a square root or a radical left in our answer, then we have a rational number. If we do have a radical left over, then it's irrational. So we're going to simplify and then state whether our answer is rational, and I just realized I forgot my directions, or irrational. So here are our 6 examples. So our first one here, let's remember when the radical is exactly the same, we just add the numbers in front. So 2 plus 3 is 5, 5 root 6. We have a square root still, so it's irrational. Here we have two fractions, negative 1/4 plus 3/5. So let's go ahead and get a common denominator so that we can add them together. So my common denominator is going to be 20. We'll multiply top and bottom here by 5 to get that 20. So we have negative 5. This fraction will be by 4, 12 over 20. When we add these together, we get 7 over 20. Well, that's a fraction, so that means our answer is rational. Okay, number 3. We're going to distribute our negative. 3 plus 7 root 2. Two negatives here make a positive, so it'll become plus 5. Negative, and then a negative and a positive will be negative 7 root 2. So when we add like terms, we have 7 root 2 and negative 7 root 2. Well, that adds up to 0. 3 plus 5 is 8, so we get our answer of 8. 8, we can write that as 8 over 1, meaning it's rational. Number 4, we're going to multiply. So when we multiply radicals, we go outside with outside and inside with inside. Try reducing your radical. So 20 square root of 25, we have a pair of 5s, so this can be 14 times 5. Well, 14 times 5 will give us 70. That can be written as 70 over 1, so it's rational. Okay, number 5. Just like in 4, we're going to multiply outside with outside, so there's a 1 there. 4 times 1 is 4. Inside with inside, 6 times 8 is 48. Now let's try to simplify. So we'll have 4 and 12, 2 and 2, 3 and 4, 2 and 2. So I have 2 pairs of 2's. So the 4 that's already out there, and a 2 for each pair, with a square root 3 left over. So when we finish simplifying this, 4 times 2 is 8, 8 times 2 is 16. So we have 16 square root 3. We still have a radical, so it's irrational. Okay, last one, this is a division. So remember, we can't have a radical in the bottom, so we multiply top and bottom by root 3. So on top, we're going to have 7 square root 225 over square root 9. Square root of 225, let's see, we can break that down into 75 times 3. 75 is 25 times 2. Nope, 25 times 3. And then 25 is 5 times 5. So I have a pair of 3's and a pair of 5's. So that'll become 7 times 3 times 5. There's nothing left over, meaning it was a perfect square. Square root of 9 is 3. So if we multiply on top, what we have, 7 times 5 times 3, we get 105. 105 divided by 3 will give us 35. That can be written as 35 over 1, so it's rational. So pretty much what you're going to be doing on your assignment today is you're going to be given a bunch of expressions like 1 through 6. And on those you're going to simplify the expression. So like 5 root 6, that's my simplified answer. And then you're also going to state if it's rational or irrational. And something you might want to notice is if you notice any patterns, that'd be a good thing. Because the backside, you're going to answer some questions about potential patterns. And so use the front side where you did all of this work to help you answer the questions on the back about rational and irrational expressions. When you're done with your 8-5 worksheet, Mrs. Burton will give you a review that'll help you prepare for your quiz, and we'll go over that review tomorrow before you take your quiz.